Welcome to the MBB 410 video course. So this is officially the first video and we are going to be looking at just an introduction to MBB, what MBB is about, the different resources available, and just generally how to succeed in MBB 410. So regardless of what your goal is, if you want to get a distinction, if you want to just pass, today we're going to be diving into, if you just follow all the contents, if you do all the recommended problems, if you do everything, you can get your distinction. All the content I cover aim to cover what's the most important things to look out for. So basically the things we're going to focus on is the stuff that you'll be tested on in your tutorials, in your semester tests, in the exams. So it's just the most important uh, information and the most important things to look at so that we know exactly or you are comfortable with what will be tested and you have all the tools and all the know-how on how to answer your questions. And we're also going to be focusing on understanding and just the most important things in MBB 410 because it is quite a big module. There's a lot of work to be covered, but I plan to reduce that for you and just to focus on what's the most essential thing because it is about application and it's a very, very practical module. So you just have to do lots of problems and I do give you problems and we will be looking at a lot of problems. But today, before we continue with anything, uh, we we're just gonna jump straight into what MBB is about and all the different resources. So MBB is it's mechanical engineering modules. So as you would expect, it's and it's also about control systems. So it's control of mechanical systems. So as mechanical engineers, we are going to be working in industry with experiments with different systems where we'll have to measure things, where we will have to uh, control things. We're going to have to control pumps. We're going to have to control different systems, give it us manually controlling it or autonomously controlling it. So so we will be controlling different mechanical systems and the different systems as mechanical engineers that we can expect and what is tested in MBB is you can look at a heat transfer system. We can address rotational disks. You can address a spring system, a suspension system, a water tank, a motor. So motors are quite a big one because motors control a lot of different mechanical parts, such as airplane wing, train, like a train tilting. There's different applications of where motors can be used. You can even use motors in pumps, like water pumps and so forth. So and this is just a standard block diagram, but we will get into what that is and what that is about. And yeah, so that's just, so basically MBB is just, we're looking at the control of mechanical systems. Now, if you want to get information quickly, because there is a lot of information on MBB and like control systems is quite broad in the textbook, there's a lot of information there. So if you want to get an understanding quickly and just get an idea so that you can start applying, because MBB is about application, then there is resources available to you. So we have Brian Douglas. So this is on YouTube. I highly recommend you look at Brian Douglas videos, but they will become more important as you progress into MBB. So after semester test 1, when you're in semester test 2, you don't have to worry. Well, semester test 1, semester test 1 is more basic, but semester test 1 afterwards, when you start to get into more advanced applications with controllers, his work becomes very, very important. It's great work. His videos, they cover everything and they just break down the idea very practical. And so he'll be one of your key resources for explaining ideas and for theory so that you can get the application very quickly. So he's a brilliant reference. And then there's also this lady. Uh, so there's also this lady here, katkimshow. She's very, very good at explaining different control theories, sometimes a bit advanced, sometimes she uses different variables and stuff. But the idea is to remember that I'm just providing resources so where you can get ideas and so forth, and she's really good. So, yeah, so there's also resources available to you. So there's this drive that has been shared with you. The link should be available in the description. So this will take you, so we go to MBB 410, and then, yeah, so we'll see we have different resources here. So I then tend to, yeah, so we've got different resources available, and I highly recommend you look into these resources. They're very, very good. And yeah, so we have notes, we have tests and exams, we have a lot of different past resources, and it's very, very good. All free, all distributed. This has been contributed by students and other students. So yeah. Now, yeah, so that's pretty much what's available. But now let's actually look at MBB. Like let's understand what are we looking at? Like what is a control system? Like we need to really understand this idea. So I have my little whiteboard here. And then yeah, so I got my whiteboard. And yeah, we can literally just jump into control systems, right? So just to explain the idea of control systems, because I really just want to make this very quick. You have two types of control systems. You have an open loop control system. Open loop, I'm just going to say CS for control system. So yeah, we have an open loop control system, and then we have a closed loop control system. So these are the two most fundamental control systems, right? So then an open loop control system. So we have an open loop control system. This is very, very straightforward. So let me just close all the stuff in the background, and then yeah, so we can just have different programs there. So an open loop control system, it's not an autonomous system. So an open loop control system is, you can essentially imagine it as a manual control, right? But what we're doing is we're controlling like a lever, and then that's turning something, and then that's turning something. So in a classic example would be, so we have a steering wheel of a car. So let's say this is our steering wheel, right? And then we obviously turn the steering wheel with theta. So I'll call this theta wheel, and it varies with time as we're driving. So we have some car, right? So we have some car, and we have a steering wheel. So this is our steering wheel. So we have a steering wheel, and what we need to do now is we going to turn the steering wheel, and now what's going to happen? That's going to turn the tires. So we go from theta t into our control system. So a controller, like we're controlling the wheel, then that goes through uh, the like there's an axial shaft. Basically, there's a shaft that's connected to the steering wheel. There's some mechanical mechanism that is attached to the wheels, and you turn the tire, and then that results in the wheels turning, right? Like at an angle. So the wheels going for an angle. So we have so so yeah, so we have our uh, yeah, so we controlling this thing here, our steering wheel. So let's actually rather call it, let's call it the theta S. So we control our steering wheel. We can also call it SW for steering wheel. And then so that turns at an angle. And then what does that result in? That results in the tires turning. So which is, we can say theta wheel turns. So this results in these two. So we're basically going from turning a steering wheel to turning the wheel. So the wheel will turn, right? So our control system for this example can look something like this. So we have theta S wheel going into our system. But what we need to do is we need to convert, wait, thing, let's turn this off. So before we do anything, so we basically we have T as there's something going on here. There's our mechanical mechanism, steering system, we can say, or mechanical steering system, right? So I can even just get rid of this box. We can have like a proper box there. So into our mechanical system, we're putting an angle in there. So we're putting an angle into our mechanical system, and then what we're getting out is we're getting out our so we're putting so we're putting our angle of our steering wheel into our mechanical system, and then what we're getting out is we're getting the tires that are moving. So we're getting we're getting omega wheel of time t out, right? But now in control, we use, instead of using time for our control system, we use s. So what we like to do is we will convert our input into something more understandable, something that's easier to understand, that's easier to work with math, and that's called a transfer function. So now, so we work with a transfer function, and this is basically just f in terms of s. So what this allows us to do is it's basically, it just makes the transfer function, the whole idea of it is it just makes math easier. That's it. So it makes us relating different components and different systems, or different, like, so in a mechanical system there's different components, or in any system there's different parts of that system, and each part does something. So that something it does is we convert that into a transfer function. So basically another way you can look at it is a transfer function, it describes cause and effect. That's all it does, describes cause and effect. So an effect. So our cause is our input, and our effect is our output, right? So then what this looks like, if we had to now go back to our controller, our steering wheel controller, this it looks like this. So all we do is we convert. So originally we had our controller here, we had our controller there, but what we need to do now is we had it in terms of time, our input in terms of time. So this is our input, this is our output here. So the input of the steering angle, and the output is the angle of the wheel, right? And remember that there's no feedback, or there's nothing here. This is a manual control system, and that's why it's open loop. So if we want to convert that into so if we want to convert that into a controller, then we'll just have, so we can understand it better, we'll use the Laplace transform. So we have theta, so we have the steering wheel angle, right? Then this, if we do a Laplace transform, Laplace is this beautiful thing that allows us to go to the S plane, or to a unitless domain. So that's why we use it, because it just makes math easier. That's why we do it. So then this will equal to